All right, so last video we talked about how we build this factor that's going to fix the fact that our equation wasn't exact. And we kind of accepted that it existed and then found the formula that is supposed to work. And now we're just going to compute it and plug it in and see what happens. So let's see, e to the integral of 1 of x dx. The integral of 1 of for x dx is the natural log of x. E to the natural log just cancels out, so we're left with x. And so the ODE can be written as we just take this v squared minus 32x dx plus vx dv. And we multiply everything through by x. We've got x times v squared minus 32x dx plus vx squared dv is equal to v times 0. So that's just xv squared minus 32x squared dx plus vx squared dv equal to 0. And if you wanted to check that that's exact, you could. Sort of the derivative of this with respect to v is 2xv, and the derivative of this with respect to x is 2xv. Those two things are the same, so this is an exact equation. Because it's an exact equation, we can go ahead and just solve this the way that we know how to deal with exact equations. So we know f is equal to the integral of m, so x v squared minus 32x squared with respect to x. So that's going to be 1/2 x squared v squared minus 32 over 3x cubed plus some function of g, some function g of v that we don't really know what it is. And so then we say g is f minus everything we just found, 1/2 x squared v squared minus 32 over 3, plus 32 over 3x cubed. So g prime of v is going to be df dv, but that's just our n, vx squared. And then take the derivative with respect to v of minus 1/2 x squared v squared. That gives us minus 2 over 2 x squared v, so minus x squared v. And then plus, oh no, make that a lot smaller. Plus the derivative with respect to v of 32 over 3x cubed, but that's just 0. Turns out g prime of v is 0. Now, the next thing you usually do is you integrate to find what g actually is. So g is the integral of g prime of v with respect to v. So that's the integral of 0 with respect to v. And this is the part where you might get a little bit stuck because I sort of swept it under the rug in the first example. But when I took these integrals right here, see, when I take my first one, integrating f, I add on my g of y. So I don't have to worry about an unknown constant because g of y is my unknown constant. But when I integrate to find g of y, I didn't add on a constant. And the reason is because when I set f equal to c, it actually doesn't matter. But when you get to this point and you're looking at an integral of 0, you would say, I don't know how to integrate 0 except to make it a constant. So if you wanted to, you could say, okay, that's a constant. Then you know f is equal to 1/2 x squared v squared minus 32 over 3x cubed plus a constant. I'm actually going to make that first constant k because what we usually do next is we set f equal to c. So we're going to say, okay, 1/2 x squared v squared minus 32 over 3x cubed plus k is equal to c. Or 1/2 x squared v squared minus 32 over 3x cubed is equal to some other constant c tilde. And so it doesn't matter if you do or don't remember to add an unknown constant when you take this indefinite integral of g prime of v to find g. All that matters is that you make sure you combine everything at the end so you only have one unknown constant. I'm going to say right here. Make sure you only have one unknown constant. And then sort of the last step that we ever have is we have to solve for the variable we're trying to find. So we just solve for y equals to some stuff, or in our case, v equal to some stuff. So let's see, I've got 1/2 x squared v squared is equal to c tilde plus 32 over 3x cubed. So v squared is equal to 2 times c tilde plus 32 over 3x cubed, all divided by x squared. So v is equal to the square root of all that stuff. Oh. Just like that. And then we didn't have an initial condition for this problem, so we were just finding the general solution. If we had an initial condition, this is the point where we would plug it in and solve for c. But we don't have to do that here. Let's see. So I want to talk a little bit about why that factor we added on worked. But I think what I'm going to do is go ahead and stop here, start the next video, just in case it runs a little over 3 minutes.